Good day, everybody. Thank you all for joining on this new webinar for PRAESENSA. Today, we will be talking about multi-subnet design considerations. Yeah, as you see on this slide, the webinar is being recorded, so afterwards you can simply review it. If you have any questions, please save them till the end and put them in the chat box so that we can go through them at the end of the presentation. So as you see here, the chat function, you can find it on the right bottom corner of the user interface of WebEx. Please make sure that if you post a question that you send it to all panelists so that we can receive your question and go through them. So today, myself, Maarten de Winks, Marketing Manager for Public Address and Voice Alarm, will be the host of this meeting, and I'm supported today by Anton Thiele, Application Design Engineer for Public Address and Voice Alarm Systems. So short introduction, what we'll be talking about. So if we have a setup with multiple buildings, often multi-subnet comes into play. So Anton will run you today through what does this all mean? What do you need to consider? How do you make such a system setup? And also what when network design considerations are to be made. And afterwards, there is a short demonstration to show you a thing or two. Anton, if I may hand over to you.
Okay, yeah, thank you. I hope you can hear me clear.
Yes, loud and clear, Anton.
Okay, good. Yeah, thanks for the introduction, Maarten. So let's move on then to the multi-subnet design. Yeah, for what is LAN actually? So when you go talk about multi-subnet design, you must first of all understand what a local area network is about. So yeah, this is a group of logical group of networking devices. And it's the important thing is here that it's in the same broadcast domain. You can consider like here broadcast domains, for example, it could be a building, but it could also be when you not talk about real IP devices, you could also think about a broadcast domain like in one and the same meeting room where everyone can directly talk to each other and everyone can hear each other. That's like a broadcast domain. So when you send something, everyone there and locally in that area can receive that information or that audio. So that's also how networks are set up and how local area networks are set up. So yeah, what to do in case you want to have multiple broadcast domains, like if you have multiple meeting rooms or if you have multiple buildings. Yeah, in that case, you need to have separate LANs. So you need to have separate local area networks in that case. And yeah, and that, like here in this picture, you can have building one, which is connected to a switch or just interconnected devices there, which run in their local broadcast domain in their local area network. And then you can have a building 2 and 3 maybe together combined into a separate local area network. Yeah, and so still because of that switch they can talk to each other here. They can so everything what is in building 2 is also being heard in building 3 as it is all on the same local area network. And the packets are only switched between ports that are designated to the same LAN. So in this case we do nothing. So we have one switch which has only one LAN here. Here is also a switch which has just one local area network. So it's just a default out-of-the-box switch which interconnects these two buildings together here. And here you have this building 1 which is interconnected. Yeah. So yeah, then the next step is then about VLAN, virtual local area network. And well, a VLAN is a logical group of networking devices in the same broadcast domain. And now you see here there's only one switch. Only one switch is here available, and which can still be assigned to then the port can be assigned to a particular VLAN, and that's actually the same as like you would use two different switches, but now you have only one switch which can have two different broadcast domains So you define that per port. So you say here port 10 is only allowed to have a connection to VLAN 1 in this case, and maybe port 2 and 3 have VLAN 2 configured. So these two ports talk to each other. They have their own broadcast domain, and this VLAN 1 is, although it's using the same switch, is then you having the port 10 connected to the building 1, for example. So yeah, this is then to allow you separate traffic from different devices into different segments of the same physical network switch. That's many often used when you have multiple VLANs. You don't want to have every time a separate switch for a particular VLAN. Now you can, now per port, you can assign that. This is normally how you can set up multiple VLANs. Well, but how now can these VLANs communicate with each other? Because I just mentioned they have their own broadcast domain. So if you here shout something which you want to reach VLAN 2, that will not be reached if you do not have something special there, because this is simply switching all the packets from VLAN 1 maybe to other ports which are assigned to VLAN 1, but they will not reach VLAN 2. Yeah, so it's really isolated from each other. So in that case, yeah, you need to have a router to pick up the packets from one to frames from one and to put that into the other. So it picks it out here and it will put that in the other VLAN. If you have a standard switch cannot do that, and you then need to have a router to be able to interface between these different VLANs. So a router. Yeah, another option. Well, no, let's come to next. So a router here. So you have a router here which then can interconnect, and you can say here you have maybe a VLAN 1 on this side, and you have a VLAN 2 on this side with maybe switches here again at the different locations, and then this router is then interconnects the two different VLANs. So you can also have, besides a router, you could have a layer 3 switch. And what's now the difference? Well, a layer 3 switch has a switch and a router inside. So that means that in that case, you can again, like any standard switch, assign VLANs to particular ports. And it can also do routing between the different VLANs. So that's more or less combined. Here you might need separates. You need to have switches and routers. And here it is combined into one device. Yeah. Yeah, so that can now do then can make the traffic from VLAN 1 from this broadcast domain to reach the other broadcast domain. Yeah, then another thing, when now we talked about VLANs, what's then the difference between VLANs and subnets? Because we were talking here about multi-subnet design. And yeah, both deal with the segmenting of networks. Now the difference is if you know the OSI layer model, so that's standard Ethernet layer model, the VLANs is OSI layer 2 and subnets are a layer higher. They are on layer 3. Layer 2 means Ethernet frames, so on MAC addresses and physical MAC addresses, which then they don't communicate on IP, they just communicate via their physical MAC address and the destination MAC addresses. And so they don't do anything with IP normally, a switch. So only when you go to a higher level, then you get into that IP domain. And yeah, and that's where you also then see the segmentation based on subnets. Yeah. Normally, that's in the rule of thumb, is that you create a one-to-one relationship between a VLAN and a subnet. So that means if you would have here created a VLAN 1, and you have on the left side, and you have in this broadcast domain, and in the second broadcast domain, you have created that VLAN 2. So that you also have a VLAN like 192.168.10.xxx, and here maybe 192.168.20.xxx. So that's then their own. They have their link between the one-to-one relationship is then normally a rule of thumb to do. Yeah, so it's not mandatory, and there are some exceptions, but I would, when you create a design, think in that direction. So always have a subnet IP assignments created, which are linked to that particular VLAN. So each network or VLAN has again its own broadcast domain, as already mentioned, and the router serves as a boundary between these broadcast domains. So that's for both the networks, for the IP networks, as for the VLANs in this case. So that really then has two different IP ranges also. Yeah? When you create your design later, you must think about which IP range you select here, and based on your subnet mask, you have then your IP assignment set for the left for domain A and for domain B. Yeah, why would you like in general to split broadcast domains? Why do you want to do multi-subnet? And that's an elementary question actually for this webinar. There are some reasons here. I mentioned them. So it's the ease of administration. You can imagine also when you compare it with for example large office buildings, there you would not like to mix everything all in one large network. For example, the sales department, maybe you give a separate IP range and broadcast domain. You give your logistics a separate broadcast domain. So you will really segment these that network because of administration and of management. The same thing you could do for your PA system, for your public address system. For example, if you have an airport, for example, where you would have your land site maybe on a separate network than the airside area. Yeah? So in that case, you can segment it, and also in that case reduce the broadcast traffic, which go from it's used in this area to this one. So that means not that all multicast and all other traffic which is generated here will automatically be reached at the second broadcast domain. That's something which then the router manages. Only when you have a destination in that area, it will forward the traffic, and else it will simply not forward it, and this area will not see it. Yeah. So it will reduce, in that case, the broadcast traffic. So it's not anymore one large broadcast domain, but it has different areas, like the comparison with the meeting rooms. I have here left meeting room and right meeting room. If you start talking in the left side, you don't automatically hear that at the right side, so it's more quiet. So it will reduce the broadcast traffic, which also then makes it more scalable. You can imagine now you can just create let's say almost unlimited amount of broadcast domains with different meeting rooms, and they can all, in that case, scale. You don't disturb each other, and they run independently. It can also be more secure because you can better monitor what's inside that local broadcast domain, and everything what goes out or comes in can maybe go through a firewall or be verified on its authenticity, and so you can have a higher security level in that case. And maybe another thing that I didn't mention here is also reliability, because if here a device might break and might send a very high amount of traffic, it could disturb everything. If it is only happening here, then at least only this segment is affected and not the other segments. So you can with that also have a higher reliability in case you have a multi-subnet design. This normally is done really in larger installations. So when you have a local area, says already local area network, and when you then here have when you have a big site, a very big campus, you can better segment it into different subnets and to be more safe and to have these advantages which I just mentioned here. Yeah. So then let's look in the next step to the system setup. Yeah, in a single VLAN design, and now it becomes a little bit more technical, the link local assigns IP addresses to PRAESENSA devices automatically. And this is something which is also like in any PC or laptop. It's standard IP technology where you normally, if you configure your PC in auto assignment, auto IP assignment, and you would not have a DHCP server somewhere, then automatically your local PC would go into a link local range in 169.254.x.x, and this is an auto IP assignment. Our PRAESENSA devices are doing the same. So in case you have them set and it's default set by auto assignment, then they will automatically, if they don't see an IP address, a DHCP server, sorry, then they will jump into that link local address range. So auto config mode is that. When you look at, so that's IP assignment, when you look at clocking, in a single VLAN system where you have your PRAESENSA system set up, then the system controller is the audio clock master. PTP is something, precision time protocol. That's a protocol for audio synchronization. So it's not for the clock to be set on an NTP server. This is really for the audio synchronization. We are using for that PTP version 1. And the system controller is normally the clock master here. Yeah. And automatically. Another thing when you would have a single VLAN design is that PRAESENSA devices offer device discovery. So they will have every device will have its own database stored locally, and they will just send in multicast around, hey, I am a call station and I have this IP address, something like that. And so also the system controller does this, also the amplifier, all the devices will just broadcast away, like in the meeting room, everyone is introducing themselves. Yeah. So, and they can all hear that. So everyone remembers when after their introduction, what his name is and what the IP address is in this case. So that's then easy for them if they need to communicate with that device, that they can directly know what is in the network and how they can reach it. Yeah. So normally via a multicast DNS is that the case. It's plug and play. Yeah. So that's the advantage all of using a single VLAN. So you don't have to do anything here. You can just use your PRAESENSA devices, you interconnect them, and it's an auto-configured network. Yeah, very easy as that. Yeah, in a multi-VLAN design, it's a multi-subnet, multi-VLAN. Yeah, it must be connected to a router. That's what I already mentioned, which is able to route unicast and multicast traffic. As we are using a lot of multicast, because you can imagine that a call station, when it makes a call and it will reach an amplifier in another subnet, that you need to have that audio set then through multicast to the other side, and that's by default in this case. So in PRAESENSA, we always are using multicast. We're not switching between unicast and multicast. That would make it too complex and also less flexible. Yeah. So it is in this case easier to add zones and to remove zones, so you can fully flexibly add and remove broadcast channels to amplifiers. So that's the reason why we are using here multicast, and also then in that case it will be limited in bandwidth. Besides that, now the DNS, the multicast DNS, MDNS does not work anymore, and also your IP assignments do not anymore. That link local will not work here. So now you need to have a DHCP service to be able to assign IP addresses to the devices. Or you must have fixed IP addresses programmed into the devices. Both options are possible. Yeah. You must have Yeah, so every VLAN must have its own subnet of IP addresses. I already mentioned that earlier, to allow proper layer 3 routing. So you have that 192.168.10, for example, and the other has .20. So you have your good IP addresses configured there to set this to allow proper routing in the switch we are going to use. So for example, here with 3 subnets, you could use these type of addresses. Yeah, and then normally your subnet mask is then in this case 255.255.255.0. So this is your network address, and your host address is then the X here at the right side. Yeah, so that's something which you need to proper set up. Yeah, and then you have your clocking. Yeah, don't scare down from this picture. I will explain it to you. So in a multi-VLAN system, each VLAN needs to have a PTP boundary clock device. So I just mentioned the PTP is the precision time protocol for the audio clock synchronization. And yeah, normally PTP works with multicast. That means, again, there is one clock master somewhere, and that clock master, that was normally in a single VLAN, it was the system controller. It will send out clock signals to synchronize all the other devices. So normally a system controller manages this. Yeah. Yeah. In case you have multiple subnets, this multicast, this PTP, does not go over the router. Well, even though you would have multicast routing enabled on a switch, this will not go through because PTP version 1, which we are using, has they call it a time to live of 1, which means that it cannot go over the router into other subnets. Yeah, so that means it's only for its local area. So now you need to have something like which is called a boundary clock device, which is able to transfer the clock signal to the other subnet. Yeah, that's all for clock synchronization. So that's to synchronize the PTP clock, every device with the PTP clock grandmaster. In this case, and I mentioned them already, we have for this an ARNI. We call this an ARNI. That's an audio routed network interface, which is required in every subnet and every VLAN to be able to manage this clocking. Yeah, so that means the ARNI-E in that case will become the grandmaster, and it will sync the ARNI-S, which is installed in any of the other subnets, to get the proper clocking received, and from there it will again multicast out the clock signals to the different devices. So that's something which is managed by that ARNI. So it acts as a local clock master in its VLAN. Yeah, so that clock boundary device. So you have here now the ARNI-E, which is your grandmaster, and this ARNI-S is the boundary device in the VLAN 2. Yeah, so that has a higher priority than system controllers. Yeah, there is an option if you say besides using an ARNI-S in any of the other subnets, to use here an other device. Besides the ARNI-S, you could also have an amplifier or a system controller to act as a clock boundary device. So in that case, you would not need an ARNI-S here in that local subnet. But be aware that the operation of this buildings in this case it's building 2 and 3 depend in that case on the availability of the ARNI-E. So I would say it's better just to use also here an ARNI-S in every subnet, which is then really your local clock master in that area, and you do not depend the operation of this area to the VLAN 1. Yeah, so that's something which you should be care of. So normally you have then the ARNIs in every subnet acting as your boundary clock device. And then we talk about the DNS server. I just mentioned in a single VLAN, you have your multicast DNS. Everyone, like in the meeting room, shouts its own name, and I have this IP address, and you will remember from all the devices what the IP addresses are. But in a multi-VLAN system, you don't know what is on the other side, what is in the other meeting room. So PRAESENSA is not connecting on IP address, but on host names. So it means you do not do anything on IP configuration in that case, normally in PRAESENSA. So it's always based on host names. This is because that's also a higher security level within PRAESENSA. We do everything encrypted there to connect. So the RNE or RNS again can also serve as a DNS server for the Omnio domain. That means now instead of that every device has its own multicast DNS database which remembers all the host names and IP addresses, now this RNE does this. So the RNE, but also the RNS and the other subnets have their own database where is shown now, well, I have the system controller, I have the call station with this name and this IP address. So that's now something which this RNE takes care of. So it's not anymore everywhere locally stored, but that's then really something in the RNE and the RNS managed. So that is actually the main feature, the most important feature of the RNE. Yeah, good to mention here that a standard DNS server, which you might have in a network, will but not be compatible with this Omnio domain DNS services. We are using here also encryption and specific items which are not compatible with a standard DNS server. So you really need to have an RNE if you go for multi-subnet in PRAESENSA. So multi-subnet PRAESENSA needs at least one RNE. That's the Enterprise Audio Routed Network Interface Enterprise. That's the main message here if you go for multi-subnet. And also important, an RNE does not route audio. Very important here because you could think of the name Audio Routed Network Interface that this would be a router. No, it's not. It's only for doing the things I just mentioned. So only for your registration of devices, so your DNS registrations, your clocking. It could also act as a DHCP server for IP assignments, but it does not route audio. It does not going any audio signal in or out this device. Yeah, so be aware of this. So if you go for multi-subnet design, you need to have an RNE, but you also need to have a layer 3 router. Yeah, you need to have a layer 3 switch or a router to do audio routing. Yeah, then the next step will be your network design. So yeah, I have here then again an example where I have 3 networks. I have here a service building, VLAN 10. I have a conference center at the left side, VLAN 20. I have here a router in between, and I have here a VLAN 30 with a library, like a campus example. Now you have defined your VLANs. I would not use VLAN 1 because that's a default VLAN. So if you go for multi-subnet, better not use the number 1, but start with something like 10, 20, 30 or 10, 11, 12, but don't use 1. Then you need to have everywhere in every subnet, you need to have an RNE. So I have here my main RNE, I would say the RNE in the service building, and I have at the left and the right side, I have an RNS. Yeah. Then I do something with IP assignments. So I have here 192.168.1. Maybe it's better even to use here 10, that you take it a little bit the same as VLAN 10, which is mentioned here as VLAN 10 service building. So maybe also your IP assignments, make them logic, like 192.168.10.0, that's in the network. And then everything here is in that range. And then you have your gateway. Yeah, in this case, it's 254.192.168.1.254 is your gateway address. Yeah, and then you have your RNE itself, which has an IP address, which is your DNS server, and that's also here with the RNS the same. Yeah, so one router, 3 VLANs, and the main system network is at the service building. Yeah, so that's how the design looks like here. Yeah, the rules, some design rules to take into account. The ambient noise sensor and the IM16C8 there's an I/O module. They need to be in the same VLAN as the system controller. So they are not yet ANI aware. So that means if you create a multi-subnet design, be always certain that you have your noise sensors and your I/O modules in the same VLAN as the system controller. Yeah, that's a design constraint which you need to take into account. This might change in the future, but for now, this is not the case. Duty and corresponding standby controller need to be in the same VLAN. So that's also important. When you look at the duty and standby controller, they are communicating on a layer 2, on an Ethernet level with each other, in CARP, they call it, and that needs to be in the same VLAN. So if you have a duty and standby controller, always have them in the same broadcast domain in the same VLAN. Yeah. And another one is that a duty and corresponding standby ARNI need to be in the same VLAN. Yeah, so that doesn't mean that an ARNI S that must be in another VLAN, but if you have a main, there's a duty and a standby ARNI E, or you have a duty and a standby ARNI S, they need to be in the same VLAN. ARNI E's and ARNI S. Yeah. So define one, the main VLAN, where to install the ARNI E. Yeah. So you need at least to have an ARNI E in your network and optionally a standby ARNI E. Yeah. Other subnets should then have an ARNI S and optionally a standby ARNI S. And then have at least one router which complies to the Omnio requirements. Yeah. So which are listed in chapter 4.6 of the installation manual. So also take a look at that. Also mentioned, a subnet could operate without ARNI S, but in that case, that requires at least an amplifier or a controller in that subnet. So you cannot have a separate subnet with only a call station. That will not work. So then you need to have an ARNI S there, or at least one amplifier or a controller because of the clock synchronization. Only these devices can also act as a boundary clock device. Yeah. And in that case, also the devices in that subnet cannot register to any of these devices. So then it must register to the ARNI E of the other subnets, which makes them dependent from that ARNI E and from that other subnet. So from that perspective, it's recommended to use ARNI S's, but I want to mention it, there are some exceptions possible here. Yeah, devices can be registered at the ARNI E in another subnet. Yeah, operation depends on the availability of the ARNI E in the other subnet in that case, if you are going to operate without ARNI S in one of the other subnets. Yeah, but be aware of these constraints in that case. Maximum 450 devices can be registered to an ARNI E or an ARNI S. So that's a limit here. As you know, PRAESENSA system limit itself is 250 devices. So you will not easily go beyond this, but maybe in case you consider a multi-controller, then need also to take this into account. Yeah. And then you can have with the ARNI S's, you can have maximum 40 subnets. So that means you can then have in that case one ARNI E and 39 ARNI S devices. Yeah. That are the design rules to take into consideration. Then I have here an example of a multi-subnet design. I have here somewhere an interconnect to a corporate network, for example, through an OSPF interface or via a routing interface. Only layer 3, only IP, no Ethernet going out here. And they can be firewalled at the corporate side of the network. So they can really put a firewall in between to ensure that everything is isolated and only you have restricted access to your PA network. Yeah, then I have mentioned here the IE5000, which is an EN54 certified switch of Cisco, which can have a horizontal stack connection, which means that in principle this behaves as one large layer 3 switch, although it has two separate and maybe even on distance devices. So it can be fully redundant in that case. Yeah, and then in this case we have three subsystems on the VLAN 10, 11, and 12, where they are all on the same broadcast domain in VLAN 10. They are connected, like here in a loop, I would say here, VLAN 10, connected to both switches here, on this one and on this one. And here at the left side the same. So you have here your VLAN 10 going to this switch and going to this switch. Yeah. The same for the others. So VLAN 11 and VLAN 12. So you can now have at this side, you can have a duty controller, you can have on this side a standby controller, as long as they are in the same VLAN, it's fine. Same for the RNE, you can have a duty and a standby RNE, and maybe have some additional switches inside our ESAP2S, for example. And here are all the same. So you have your duty RNES, you have your standby RNES, and you have your system controller duty standby. And now you can interconnect all your devices here in this all the same VLAN 11. So that's all fine. Here as well, we have again a duty and a standby, and with so actually already you see now you have three different networks and three different systems. Yeah, you could also think of having only a system controller here in 10, and then here don't have any system controller, no 11 and no 12, and everything is controlled by the system controller in 10. Yeah, so that's also an option. So that's so there are multiple possibilities here. But this is the way how you could set up a fully redundant system design multi-subnet. Yeah. Maybe also good to mention here, we talked many often about the hop count. So in this case, your hop count is really limited to this area here. So you can have here a maximum hop count of 20. So you can have multiple loops of maximum 20 devices and of 22 devices, and including the core. And you have that at the right side as well. So this is also an advantage of having a multi-subnet design, that you can everywhere have your hop counts and your local spanning tree domains set up. Yeah. So then I would like to briefly show you my setup here, as I have here beside me. What I have connected here, just as a reference, a little bit looks like the drawing before, but it's slightly more simple, as I don't have so many switches here and routers. But I have the layer 3 switch here. That's our EN54 certified switch. I have connected that to 3 VLANs. So I do port assignment at the front to the different ports, where I say some of them are assigned to VLAN 10, some are assigned to VLAN 11, and some are assigned to VLAN 12. I have here my RNEs. I have here a main and a duty and a standby RNE, and I have a duty and a standby system controller at this site. I also have here an ESAP2S, Ethernet Vantex switch connected, which is then automatically also part of the VLAN 10. I don't need to configure anything here, because it's all already, the VLAN assignment is defined in the layer 3 switch. So here it's just all the same. You don't have to, it's more or less directly connecting, and it's part of this broadcast domain. So then the VLAN 11, I have an RNES, only one. I don't have a standby here in this case now. And here I have a call station. I have an amplifier. I have an MPS 3, on this side. And here at the right side, I have also an RNES with only a call station. And now still we can use that, because this is also my boundary device. So this is the setup. Now let me try to move to the, give me a second. So I'm now here at the, sorry for my hassle here. So I have here my picture of the Arnis. I have here a call station on top, as you can see. Yeah, I have here a music player. It's not Bosch. It's just a third party with eight analog in and having 8 Dante out. There's a music source connected to it. I have here the Arni, so I have here an Arni E and a backup Arni E. I have here an Arni S for the second VLAN 11, and I have an Arni S for the VLAN 12. And this is the switch. So this is this layer 3 switch of Cisco, the IE5000. Yeah, and so now it doesn't matter if you have, for example, that that sound can then be easily being transferred. If I select here the music sources and this can be easily played. It doesn't matter where the location is, so you can just make your set your music and play in every different subnet, in every different broadcast domain. So you can manage it all. You can also, of course, make your calls and make your announcements into all the other areas. So that's something which is straightforward. When you look at the configuration side, come on. Yeah. Oh yeah, I need to be. I'm here in a diagnostics page of the Arni. I think I need to log in again because it was. So you can see here now where this is this 1010 of the Arni in this case, of the Arni E, and you can see how it is configured. I have so it's a DNS server. There's a gateway. You can also see the domain name which is configured. So all devices will need to have that parental Bosch.omnio in this local area network, and they have their DNS name 10.10. So that's the way how that is set up. Yeah, when you look at the clock boundary, you can see here, this can be ignored, that's something old, but we have here 2 boundaries where you see the 10.10, that's the clock boundary device in the VLAN 10, and you can see the boundary device 11 and 12, so that are the Arni, this is the Arni S in the other subnet, and this is the Arni S in the other subnet. So you can, in that case, see also how your clocking works, and then you have some tools also to verify which devices are registered to the particular Arni, and that's what you see here. So you can see now here to that Arni, like I said, you don't have your own local table, but you see here the system controller, which is assigned to it and being registered here in this diagnose page. Yeah, so this is something which is there. When you look at the Cisco switch, this yeah, oh, okay. You can also have a look. This is Cisco IE5000, and that yeah, would give you some more insights on the connections there. So, for example, what the load would be, or what your configuration would be. So also here you can see now which ports are connected. Yeah? So can see that they and which speed they are. If there is a redundant power source connected or not, so you have your direct overview of this switch and how it is, what is connected on that switch. So that can also give you a good impression here. When you look at our network configurator tool, so that's maybe gives you also an idea on now how the assignment is. I have my system controller here, which has 2 IP addresses. That's always the case. You have a network and a host processor, and that's has in that case the IP address range in 10, the 10 network. You also have here, I have here a multi-controller setup, but that's not. We have here also a wall mount call station, which is then in the VLAN 12, as you can see, and that's in this domain VLAN 12.bosch.omnio. You have your VLAN 11, where I have my another call station, my desktop call station connected, and my MPS. And in this case, you can already see that these devices have different IP addresses, and according to my diagram, what I previously showed you. Yeah, so this diagram actually, which was just shown. So that's also how this representation look like. Yeah. So important, these ARNIs everywhere in every VLAN, having a layer 3 switch router in between, which is able to multicast routing and to be according our requirements. Yeah, that's basically how it looks like. We can also monitor these devices. I didn't mention that yet. Maybe I should do that before I go back to the login page of PRAESENSA. You can also see here, I mentioned my system controller PRAESENSA, but you can also see parent.bosch.omnio. That's always the domain, the DNS suffix of the ARNI in that case. Yeah. In the system composition, you could also add that ARNI, so you can see it here. So it's also really a device. Yeah. So it is something which is recognized as a system device. Yeah. What I did not do here yet is also to integrate the IE5000, because that's also a network switch which you could add here. So that means besides that you have your ARNI, you can also have that layer 3 switch, this IE5000, be really part of the monitoring. So that means if you have your and that can be like a network switch being added, and if you, in that case, for the switch connectivity, you have your IP address connectivity, but what and dots 1. And when you then look at the device options, you can also see with network switch, you see your IE5000, and there you can really have the model also. So this is the real model of this IE5000 switch, which can be supervised on power, and that goes through SNMP. So you need to set up the proper SNMP settings. It also supports a stacked switch, stack of 2. It can be supported and managed. So it's really dedicated, as it is also EN54 certified switch part of this. Yeah. So you can with that monitor it. For now, I leave that. Also the ARNIs. So that's also, they are also certified, and you can. In that case, I didn't mention them here all, right? But you can also indicate here that they are, of course, emergency relevant. So in that case, and so they are supervised. In case you lose connection to that ARNI, then it will also be reported. Yeah, so also from the PRAESENSA side, these components which I just mentioned are monitored and being verified. Yeah. That means this the PRAESENSA system controller monitors ARNIs, ARNISs. It monitors this layer 3 switch, And it also even monitors these ESAP2Ss. So all external devices which are here shown are also supervised by the system controller. Yeah, with that, I would like to end my presentation.